the integral has an antiderivative. Recall that in our overview video, one of the main interpretations of an integral was that it was the antiderivative. So what is the integral of f prime of x dx? Well, it's the antiderivative, that is, it's the function where we started. That is, the derivative of this piece must be what's inside here in the integral. Now, I've left something off over here on purpose. I'm going to come back to this in just a bit. Let's start by doing an example, though. What is the integral of 1 plus 2x plus 3x squared dx? That is, what function did we come from to end up with this derivative here, which we will call the integrand? A side note, the dx is there for the theory. Sometimes it helps us set up more complicated problems, but we do not integrate. That is, we do not find the antiderivative of dx. We find the antiderivative of these pieces here. So how do we find the antiderivative? One way, sometimes it's the only way, is to say the derivative of what function gave us each of these pieces. So the derivative of what equals 1? Well, the derivative of x equals 1. The derivative of what equals 2x? Well, the derivative of x squared equals 2x. The derivative of what equals 3x squared? Well, the derivative of x cubed equals 3x squared. So sometimes that's the way you have to think about this when you're doing antiderivatives. Now, the derivative of what equals 0? Well, the derivative of any constant is 0. So just because we don't put a 0 here in the integrand, meaning there might have been a function or a constant part of the function whose derivative is 0, simply implies that we need, anytime we're doing what's called an indefinite integral, an integral without limits, we need to put down a constant of integration. Where the constant of integration is this c value, or this plus c that we put there. Let's do another example. What if we want to integrate the cosine of x dx? Once again, we have to say, well, the derivative of what equals cosine? And we should know, or we have to know, that the derivative of sine of x equals cosine of x. Again, do not integrate the dx's there for the theory. Now, is this the only possible answer? Of course not. It could be sine x plus any constant of integration, because the derivative of sine x is cosine x. The derivative of any constant is 0, so I end up with my same starting place when I put the constant of integration. Do not forget to put your constant of integration. Let's look at some other integrals that we need to know. How about the integral of e to the x? What's the integral of e to the x? Well, the derivative of what equals e to the x? It's itself. So it's e to the x plus our constant of integration. What if we have something like this? The integral of k x to the n dx. Where I'm going to do the constant rule and power rule together. How can we find this integral? And there's a way to do this without saying The derivative of what equals where I end up, guessing and checking, going backwards. We can certainly do it when we have a constant in power rules, because our constant, just like with derivatives, can be ignored until we're done and then multiplied back in. Now, how can we find this? Remember, k is another constant. How can we find the integral of x to the n dx? That is, what's the integral of x to the n? Let's start by looking at the derivative of x to the n, which says we'll bring that old power down, we will multiply it, and we will subtract 1 to get the new power. The integral is the anti or opposite of the derivative, which means we can do the opposite of what we just did here to find the antiderivative. What do I mean by the opposite? Well, let's start this way. Instead of subtracting 1 from the power, we can add 1 to the power. Instead of multiplying, we're going to divide. Instead of multiplying by the old power, we're going to divide by the new power. And then don't forget your constant of integration plus c. Let's do a few examples. We're going to use constant and or power rule. Let's integrate 1 over x squared plus 1 over x cubed minus 1 over the square root of x dx. My recommendation when we do this is that you rewrite it, at least in your mind, but probably physically on your paper or wherever, in the form so that we can use the rules that we know. This is the exact same thing that we did when we learned derivatives. Sometimes we rewrite them first. Now let's find antiderivatives. This is a simple power rule which says we're going to add 1 to the power and divide by that new power. Next piece. We're going to add 1 to the -3, giving us -2, and divide by that new power. Now minus. Add 1 to the -1/2 gives us +1/2. And we're going to divide by that new power, +1/2. Plus the constant of integration c. I'm going to rewrite this one just to make it look prettier, giving us -1 over x. Then I have a minus, and then I have the 2 is still on the bottom, and then the x to the -2 becomes x squared on the bottom. Minus x to the 1/2. And instead of dividing by 1/2, I will flip and multiply by the reciprocal, giving us -2x to the 1/2, plus the constant of integration c. Let's do another example. What if we want to integrate 4x to the 7th minus 10x to the 3rd dx? What will this equal? I don't need to rewrite this one. I'm simply going to do a constant power rule in each piece. So the constant rule in the first one says we'll just leave the 4 and multiply it. And then we do x to the 8th, because we add 1 to the power, and divide by the new power. And then minus 10 times x to the add 1 to the power, divide by the new power, gives us x to the 4th over 4, plus c. And you can simplify this if you would like to. I will leave it as is. How about something like this? What if I want to integrate sine x plus 1 over x plus 1 over 1 plus x squared minus 1 over root 1 minus x squared dx? Let's put all of these other rules together into one problem, but we'll break it down and do each piece. Here, we have to go back and say the derivative of what equals each piece. You might think these are power rules or other things, but they're not. Each one of these are the end result of a derivative we should know. So how about the first piece? The derivative of what equals sine of x? Well, let's put down cosine of x. And let's check ourselves. What is the derivative of the cosine of x? Is it the sine of x? And the answer is no. The derivative of cosine of x is negative sine of x, which means the negative derivative of cosine of x equals the positive sine of x. How about the next piece? It is not a power rule. If we did the power rule, we would get x to the 0 over 0, and we don't know what that is, and in fact it's just wrong. We have to know that the derivative of what? Well, the natural log of x equals 1 over x. And without explanation here, but for now I just want you to do that, when you find the antiderivative of 1 over x, it's the natural log of the absolute value of x. The next piece. The derivative of what is 1 over 1 plus x squared? You have to know this answer. It's the arctan of x. The derivative of what is 1 over root 1 minus x squared? You have to know that the derivative of the arcsine of x gives us that. And always remember your constant of integration plus c.